next data structure that we will look at is an unbounded first in, first out queue. So we have a linked list of items and we add new items to the end of this list and remove them from the beginning. And for that we need two variables, a head were used for removing items and a tail used for inserting or adding items. We will also use a special node initially so that both of these can point somewhere, and then we can simplify the program by not having to check for a null pointer. Okay, so let's add something, and we can start with adding 2 to this. So we update the tail but don't do anything with the head, obviously, and then we can add something more and we update the tail again. Okay, let's remove the first item using the function dq, and what we do is, well, actually you can see the head doesn't point to the first item to remove, it points to the node just before it. So we set the local variable to h, no, not to h, but to this node, and we move head to the new one. And now we can free this, deallocate it, and now head is pointing there, so we can return 2, and as we can see, head now points to the node that is before the next one to remove. Okay, so okay, we have returned 2, and let's do another dq. So we set the variable h to the same as head and move head there and free this one and return 3. And if we want to dq another time, it will not work, and the reason is that head and tail are the same, or the next pointer of head is null, so it cannot remove anything. And some, well, it doesn't matter for this case, but some error code or something should be returned instead, or an etc. Okay, so let's look at the source code of this sequential code, and before we look at the parallel. So a node has a key and the next pointer to the next node. The queue has 2 pointers, head and tail. We can create a new node with the key using, well, we allocate memory for it, and then set the key, and using calloc we will set the next pointer to null. Okay, it's actually not guaranteed to be a null pointer, but it's only in all realistic machines that are not from a computer museum, we can use calloc to create a null pointer. Okay, so let's look at the enqueue instead. We create a new node and add it to the end of the list and update the tail to this new node. dq, we check if the next pointer of the head is null. In that case, we don't try to remove something. Instead, we return 0. And well, we set h to the current value of head, move head, free what h points to, and then return the key that head points to. Well, it doesn't point to the key, but it points to a node with a key. Okay, so that was the sequential version. And what could complicate things in a lock-free version? And well, first of all, this is different from the stack, because in the stack we a thread can only do something with the stack pointer. But now a thread can be at any node. I mean, there is no, it's not only at the beginning or, well, it's, we all only do things at the beginning or the end of this list conceptually, but we need to, I mean, every node can be, is at some point the end of the list. So that means the next pointer has to be an atomic variable, because we need to update this next pointer to some new value atomically, and also check if it was we who should do that modification. Okay, let's look at that next.